Okay, so let's look at this problem number 1. Considering the function f of x equals x squared minus 3x plus 2 over x plus 3. We're going to find the first derivative, list any critical values, identify intervals of increase and decrease. And let's do all of that before we start thinking about the second derivative. So I'm going to pull this over to another sheet so that I can draw on that sheet. Okay, so let's take the derivative of this using our quotient rule. Let's recall our quotient rule is the derivative of the top times the bottom minus the derivative of the bottom times the top over the bottom squared. So let's use that here. So derivative of the top, we're going to get 2x minus 3. Now our bottom will tag along, minus, now the derivative of the bottom is just going to be 1, and the top's going to tag along, and I'm really close to the edge here, so we'll see if I can. That is supposed to be a 2. I'm just really bad at drawing with a mouse. So that's a 2 right there. Over the bottom squared. Okay, now let's clean this up. Let's multiply out the top here. So I'm going to have 2x times x is 2x squared. 2x times 3 is 6x. Negative 3 times x is negative 3x. And negative 3 times 3 is negative 9. And then let's distribute that minus 1. So we'll have minus x squared plus 3x minus 2, still over our bottom squared. And let's add like terms on top here. All right, so 2x squared and negative x squared is going to leave us with an x squared. 6x and negative 3x is 3x, plus this 3x over here is 6x. And then negative 9 and negative 2 is negative 11. And then x plus 3 squared on the bottom. All right, now we got our first derivative, and I believe that was what our first item asked for back here. So we're going to enter that right there. But let's list any critical values. All right, so let's go back here. And we've got to set this derivative to 0. So really we're going to set the top to 0 and the bottom to 0. And I'll start with the top to 0. This is not going to factor, so we're going to have to use the quadratic formula on it and see what we get from the quadratic formula. All right, so we'll have negative b, which will be negative 6 in this one, plus and minus. B squared will be 6 squared, minus 4 times a times c, so that's times 1 times negative 11, all over 2 times 1. And let's work that out. That'll be 36. Then we'll have negative 4 times 1 times negative 11. That's positive 44. Over 2. And let's just continue breaking that down. And that is negative 6 plus and minus, I believe, 80, square root of 80, over 2. And now let's put this into the calculator and get the two critical values that come from this. So let's see, we have negative 6 plus the square root of 80 divided by 2. And then we have negative 6 minus the square root of 80 divided by 2. All right, so I'll put the first one in, and that one is 1.472. And then I'll go ahead and do this one in my calculator, and that's going to give us negative 7.472. So there's our two critical values. But as we get ready to do our sign chart for increasing and decreasing, we also have to consider where the denominator is 0. And let's notice that negative 3, if plugged in here, that was our, or would be our vertical asymptote from the original function. That needs to go in our sign chart as well. And let's see if this thing's not going to let me go. I might have to do a new page. Okay, so for my sign chart, I've just put everything on the sign chart and rewrote my derivative here so we could plug into it. Okay, so let's choose something over to the left of negative 7.472. Let's say negative 8. I'm going to go ahead and plug negative 8 into the top and see what its sign is. So if I put that into my calculator, let's see, that'll be 64 minus 48 minus 11. That is still positive. And then no matter what I put into the bottom here, it's going to get squared, so it's going to be positive. So that's positive divided by positive. We're positive on this interval. Let's choose something in between these two numbers. Let's say negative 5. If I put negative 5 in the top of this derivative, I get 25 minus 30 minus 11. That is negative. So the top is negative. No matter what, the bottom is positive. Negative divided by positive, this will be negative. Now let's choose something in here. Let's say 0, probably the easiest thing. If I put 0 in here, the top will be negative, and the bottom, again, will be positive. Negative divided by positive, that's negative. And then, finally, let's choose something over here. Let's say 8, 2. If I put 2 into the top, let's see, that's going to be 4 plus 12 minus 11, that's positive. And of course, the bottom is always positive. So positive over positive, this is positive. So increasing. We will have negative infinity to negative 7.472. And we will have 1.472 to infinity. And then decreasing. We have to list this as two separate intervals. Don't make it one. Negative 3 is not in the domain of the function. Oops, I didn't mean to do that. And so we cannot list it in our interval. Or, we can't, it can't be in the middle of it. It has to be not included, which is what this thing means. So we have this one, and we also have negative 3 to 1.472. Now notice that F and G is asking for the max and the min. Let's just go ahead and get those, and we'll come back to E, the second derivative, here in a second. All right, so F and G is asking for the max and the min. So let's just go to our chart here, and let's notice that it's increasing before negative 7.472, so it's going up, and then afterwards it's decreasing. So that means we've got a max right there. Now this is decreasing and then decreasing, and we also know that right there is where the function is undefined, and so that's not going to be a max or a min. But let's look over here. It's decreasing beforehand, and then it's increasing afterwards. So that is a min, and then we need to plug in to get the y values so we can answer the entire question there. So we need to put each of these values back into the original function in order to find the y values for the max and the min. So we need to plug that back into the original. So the original function was x squared minus 3x plus 2 on top, so we'll have negative 7.472 squared minus 3 times negative 7.472. Or 7, I left out the 7 there. Plus 2. All over, and the bottom was x plus 3 in our original, so it's negative 7.472 plus 3. So if I put all of, whoops, sorry, didn't mean for it, the draw feature to do that. And if I put that ugly thing into the calculator, I get negative 17.944. And in a similar way, we want to put the other value, 1.472, into the original function. And then, of course, let our calculator do the work to find out what that minimum is in this case. And be careful when putting these in the calculator. You have to put all of the top in parentheses and all of the bottom in parentheses to get the correct answer. And this gives negative 0.056 if I round to 3 decimal places. And that's our minimum. Okay, now I'm going to, for the next part of this second derivative, use a different video because I am limited to 15 minutes on my video program. So I'll stop this one and go on to the second derivative in the next video.